Okay, so challenge number 2. All right, so again, same objectives for all 4 of these. So challenge number 2, increased cardiac output leads to more blood going through the pulmonary circuit, which means greater pressure. We have to minimize pulmonary pressure, otherwise bad things could happen. So the reason why is fluid can leave the bloodstream and ultimately enter the alveoli. So like it says, we need to keep the alveoli dry. We don't need them to fill up with water. And so we have to prevent edema by keeping this pulmonary pressure low. We've also got high lymphatic drainage. Okay, so your lymph system takes fluid away. All right, but we want to minimize the pressure that's in there so we don't force more water out, so we overwhelm the lymphatic system, that sort of thing. And so there's 2 ways that we can minimize pressure. The first way is we can recruit. Okay, we can recruit more capillaries. Normally at rest, we don't have blood going to all of the pulmonary capillaries in our body. Okay, we can recruit up to 3 times as many capillaries that what we're currently using. Okay, so they estimate that at any one time there's about 70 milliliters of blood in the pulmonary capillaries. We can increase that up to about 210. So most of the time they're closed off because we don't need it. The other thing that can happen is that we can distend. These capillaries can get bigger. Okay, and if they can get a little bit bigger, they can accommodate more blood. So we can recruit more capillaries, and the capillaries that we do have open can get bigger to accommodate more blood. All right, so I want you to look here at what is going on. So we've got a couple of graphs. So on the x-axis, we've got cardiac output. I'm trying to find my little colorful thing. There we go. So we've got cardiac output down here, and then we've got pulmonary vascular pressure, or pressure inside the blood vessels. Okay, and then we've got resistance. Okay, so remember the formula is flow equals pressure divided by resistance. Okay, so we've got cardiac output, which is flow. We've got pressure, which is pressure. And then you can actually, the slope of the line shows us resistance as well. All right, so we've got, and then the 2 different pressures here, we've got pulmonary artery pressure, and then we've got pulmonary wedge pressure. Pulmonary wedge pressure is just an approximation of what's going on in the pulmonary capillaries. We can't measure pressure in the pulmonary capillaries because they're so tiny. But what we can do is we can estimate it. And so basically what they do for pulmonary wedge pressure is they put a catheter into somebody that goes through the right atrium, right ventricle, pulmonary artery, and then they just basically stick that thing in as far as they can go until it becomes wedged, hence the name pulmonary wedge pressure. And that approximates pressure in the capillaries. So I want you to look and see what's going on with pressure as cardiac output increases. And the answer is that it goes up, right? So greater flow leads to a greater pressure. So what has to happen, though, is that resistance stays relatively constant, okay? We actually have a big drop once we start exercising, right? So it's relatively high, start at 1.5, and then we reduce it by almost half. And so what's happening, what's allowing us to reduce this resistance is we're dilating or distending those pulmonary capillaries, and we're also recruiting more, okay? And so if there's more places for blood to go, then there's less resistance. And so that is how we overcome the second challenge that the respiratory system has, which is minimize vascular pressure.